So let's characterize the types of fixed points that arise depending on the eigenvalues. So for reference, let me just remind you what the eigenvalues are. Lambda plus minus is equal to 1/2 t plus or minus the square root of t squared minus 4d. And the behavior of any arbitrary point in the two-dimensional state space is equal to a plus epsilon plus e to the lambda plus t plus a minus epsilon minus e to the lambda minus t, where a plus and a minus are the expansion coefficients of the initial vector on the eigenvectors themselves. So it turns out there are going to be 6 types of fixed points that can possibly exist in the two-dimensional state space. The first one is a source, and this occurs when lambda plus minus are both greater than 0 and both real. And we represent that by an open circle, and then in each of the two eigendirections the flow is away because lambda plus and lambda minus are both positive, and so it's exponential flowing away from the fixed point. So the flow is away in the eigendirections and away in all directions. Then there is the cousin, or the source, which is the sink. And this occurs when lambda plus minus are both negative and both real. And so we'll represent that as a solid dot. And then in both eigendirections, the flow is inward, and it's inward in all directions. Then the next type of fixed point is what's called a saddle. And a saddle occurs when, for example, lambda plus is greater than 0, lambda minus is less than 0, but both of them are real. And so what happens here is that at the fixed point, in one eigendirection the flow is away, and in the other direction the flow is in. So let's represent that saddle point by an x. The next type of fixed point is an unstable spiral. And this occurs when lambda plus minus are both complex, and the real part of lambda plus minus is greater than 0. And you can see just by the form of r of t that if lambda plus minus are complex, that's going to correspond to like circular motion in the complex plane, and if real part of lambda is positive, then we're going to be moving away from the fixed point. So the flow looks something like this. Then we have a stable spiral. Again, lambda plus minus is complex, but the real part of lambda is less than 0. So in this case, we have flow inward but going around in a circle, so like water circling a bathtub drain. And finally, the last type of fixed point is a center, and this occurs when lambda plus minus is pure imaginary. There is no real part. So it lies intermediate to the stable and unstable spiral in that the flow is neither towards a fixed point or away from the fixed point. So we have something that looks like this, and we have a flow which completes a circle around the fixed point. So these are the basic types of fixed points that can occur in two dimensions.